Assalamu alaikum. Today we will solve question number 11. Assume that we have a large number of students whose average weight is 150 pounds. Weights are given in pounds, and the standard deviation should also be in the same unit of measurement. And the weights are normally distributed. It is if we know that 36.4% of the students have weights between 137 and 163 pounds. What is the standard deviation of weights? So we will write first mu is equal to 150 pounds, sigma is unknown, we have to find it, and the probability is given in the form of percentage 36.4%, which is equal to 0.634. From the figure you can see in the middle the mu of the normal random variable x lies in the center, which is 150 pounds. And the 2 points around this 150 are 137 and 163, and the area between these 2 points is given as 0.634, and the area beyond these 2 points is obtained using 1 minus 0.6364 and divided by 2. Since the whole area under the curve is 1, and if the central area is given as 0.63364, then from subtracting it from 1, we can get the sum of these two extreme areas, the left tail and the right tail. The sum of both areas is equal to 1 minus 0.364, and the area on each tail is obtained by dividing this difference by 2. Now we will solve this question in such a way that an equation is obtained in which sigma unknown is involved. So at x 137 and x 163, we have to convert both of these x values into z, because there is a z scale, and in the middle of the z corresponding value of 150, the z is 0. The mean of the standardized normal variate is 0, and corresponding values of 137 on the z and 163 on the z we have to find by the standardized variate z score, which is obtained as 137 minus mu. Mu is 150 over sigma, and sigma is unknown, so it would be sigma, and the result is minus 13 by sigma. And similarly at x 163, its value is 13 by sigma, and the area between these 2 points, minus 13 by sigma is here and plus 13 by sigma is here. Between these 2 points, area is given as 0.364. So we have written it as probability 137 to x 163, and converted into the z, its values are minus 13 by sigma to z up to 13 by sigma, and its probability is given as 0.364. We can write this probability is as phi of 13 by sigma minus phi of minus 13 by sigma, using the theorem phi of A minus phi of B. So this probability is the between area of these 2 points, but beyond these 2 points, area would be written as in this form. We can write probability less than minus 13 by sigma, which can be denoted by phi of minus 13 by sigma, which is the area on the left tail. This one is equal to 0.318, and taking phi on the right side, so phi would be written as phi inverse of 0.318, and minus 13 by sigma is written on the left hand side. And we will locate this value phi inverse of 0.318 in the table 10a of phi inverse, which is the table of quantiles of standard normal distribution. This is the table of quantiles of standard normal distribution in which phi inverse of p is given, and we have to use this table. We will locate our value 0.318 under the probability column. So 0.318 is downwards, it's 31, and corresponding value under the column of 8, this one is zero point 0.4 minus 0.4733. So this is our value. So corresponding value is this one, 0.4733. So we will write it here, point minus 0.4733. And using this value, sigma is equal to minus 13 by this value is as 27.47. As the mean is given in pounds and x values are given in also in the pounds, so definitely the standard deviation must have the same unit of measurement as the unit of measurement of x variate. So x is measured in pounds, so standard deviation is also in pounds. Next question is 11th B. The statement of this question is in a normal distribution, mean is given as 40, probability 25 to 40, for it's not 45, it's 44, it's 55, is given as 0.8662, and we have to find the probability between 22 and 60. So from the figure, you can observe the mean is in the middle of the distribution. Correspondingly, on the z-score, the value is 0. So the mean of x is 40, and 25 is definitely less than this one. So we'll plot it on the left-hand side of the 40, and 55 is more than 40. So we have to plot it on the right side of the 40, which is the right tail. And between these 2 points, the shaded area is blue color lines, and this shaded area is equal to 0.8662. And the area beyond these 2 points are the unshaded area on the right tail and left tail, and this area would be equal to 1 minus 0.8662 divided by 2. Since the total probability under the curve is 1, central area is given. By subtracting central area from 1, we can have the sum of both tails areas. So by dividing this value by 2, we can get the area of on each tail, left tail and on right tail. Both are equal because 25 is, and for 55, both points are equidistant from the center point. So the both areas on the tail are also equal, and which can be obtained dividing the difference by 2. Now we will obtain the equation in which probability of the left tail is given, and using this value we will find sigma first because mu is given and sigma is unknown. In first step we will find the value of sigma. Once sigma is obtained by using both of these values, mu and sigma, we will find the probability between 20 and 60, which is the next part of this question. So at x is equal to 25, z-score would be x minus mu over sigma, is equal to minus 15 by sigma, and at the other point 55, the z-score would be 15 by sigma. So between these two points, area would be written as, this is the area, 0.8662. The probability between 25 to 55 of the x values is equal to, in the z-score, minus 15 by sigma to plus 15 by sigma. Now we will solve the left tail area. Phi of minus 15 by sigma is equal to 1 minus 0.8662 by 2, and the answer is 0.0669. We can write it as 0.067. So sigma is obtained by taking the inverse phi of minus 15 by sigma. So phi would be coming on the right hand side. So it would be written as phi inverse of 0.0669. So we will use the table of quantiles of normal distribution in which phi inverse values are given. So using this table, this is our required table, quantiles of standard normal distribution, and R value is 0.06 is here, and corresponding value of 7, because 69 is round off, it would be 7. So the value is 1 point minus 1.4985. This is the required value. So we will write it as minus 1.4985, and sigma would be calculated as 10. Now our sigma is calculated for the second part of the question, in which probability is to be calculated from 20 to 60. We have to convert both of these points into z-score first. So z on z-scores at 20 and 60 are minus 2 to 2. So we, in the same way, we can write it as probability 20 to 60 at the x scale is converted into the z scale minus 2 to 2. And using the theorem in which phi of a to b is equal to phi of b minus phi of a. So phi of 2, this is the table of phi, and the area table is used for the solution of this value. The table number 9 is this one. The values of standard normal cumulative distribution function phi of z. So ensure that phi of z should be the in the title of the table, and we will locate our value 2 here. Initially it's a negative value. Coming down on the next page, on the next page, and on the third page, 2 is at the top of the table. Its value is 0.97725. So we will write it here 0.97725, and phi of minus 2 is also searched in the same table, and its value is here. It's on the first page, this one, minus 2. So its value is 0.02275. So using this value 0.02275, we will have the answer, or the probability between 20 and 60 is 0.9545. And you can observe from this figure that the area between 25 and 55 is given as 0.8662. Whenever our point comes beyond these points, 25, so 20 must be here. We are plotting 20 here, and 20, 60 would be definitely more than 55, so it would be here. You can observe the area is increasing from 20 to 60. Previously, the area was given as 0.8662 between these 2 points 25 to 55. So whenever area is increasing, its answer is definitely more than 0.8662. And in our case, the result is 0.9545. Thank you so much for watching this video. Allah Hafiz.